Hello, welcome to the series of ASPICE sessions. This is Tota Krishna Hema, your ASPICE expert. Today we are gonna discuss about system integration and integration testing, or SYS4. So this is a big process area when compared to any other process area. So I have segregated into different slides because I want to cover each and every aspect of this. So there are system integration and integration testing. What is the purpose of it? The purpose of system integration and integration testing is to integrate the system items to produce an integrated system consistent with the system architecture design, and to ensure the system items are tested to provide evidence for compliance of the integrated system items with the system architecture design, including the interfaces between the system items. So it sounds very complex, right? But what we have to ensure is like whether all the parts of the system architecture design is implemented properly and are developed properly, and it is integrated proper we have to ensure on, like we based on the system architecture design. So the entire system integration test cases or the test specification is defined. So whatever the verification criteria which is defined, that based on the architecture design, like we have to ensure on the implementation of it. So what are the process outcomes of it? Like a system integration test strategy consists with the project plan, release plan, and the system architecture design, and what are the inputs they are describing about. So we have project plan in place because we have to know what are the timelines and what should come, like what should come first, like these all we will define in terms of MPP or the project plan. So the project plan, release plan, at what particular release, like this one will get delivered to the customer. So project plan, release plan, and the system architecture design. So the input to the system integration testing test specification is nothing but system architecture design. So to adhere to the timelines committed, so we will have project plan and release plan also into the input criteria. So a system integration testing includes the regression testing strategy is developed to test the system integration system items interaction. So first of all, we will run a complete cycle, but wherein, like if you have something which is implemented for a part, for a change, so if there is any change in the requirement, okay, or else like if there is any add on to the requirement or the change in the requirement, so that's when like we will do this regression testing. So if we miss out something, then if you want to test that particular patch of the system, then we will do the regression. So we should have, along with this normal system integration test specification, we will have we should have system integration regression strategy as well. A specification for system integration test according to the system integration test strategy is developed that is suitable to provide evidence for compliance of the integrated system items and with the system architecture design, including the interfaces between the system items. System items are integrated up to a complete integrated system according to the integration strategy. Test cases included in the system integration test specification are selected according to the system integration test strategy and the release plan. System item interactions are tested using the selected test cases, and the result of the system integration testing are recorded. Consistency and bidirectional traceability between the elements on the system architecture design and the test cases included in the system integration test specification, and the bidirectional traceability between the test cases and the test results are established, and the results of the system integration tests are summarized and identified and communicated to all affected parties. Why I have read all these process outcomes is, like in the next base practices we will get into the details of it. So it has like this particular process area has 9 base practices. So the BP1 talks about develop system integration test strategy in system, sorry, develop system integration strategy. So develop a strategy for integrating the system items consistent with the project plan and the release plan. Identify system elements based on the system architecture design and define a sequence of the integrating them. First of all, see, we have bits and pieces like of the components. Like we will have software which is separately defined, and we will have a mechanical, we will have electrical components of it. So first of all, we have to assemble everything, and we have to put software inside it, and we have to ensure like what should come first, what should come later. That means a sequence of integrating them. In while assembling also, we have to get into the sequence. So first of all, we have to put this particular screw, or first of all we have to put this particular component into the system. So this all we will do in a strategical way, right? So when you are assembling something, we will have a strategy defined. So as per the integration strategy, we have to integrate the system. Okay, all the system elements, system items to be integrated based on the system architecture design. This is nothing but system integration strategy. BB2 talks about develop system integration test strategy according to the and including regression strategy. So we have integrated system in place. So now we have to test the integrated system. So how to test this is like first we have to define a test specification or test strategy we have to define. So how will you define a test strategy is like we from the architecture design we have to define integration test strategy. So even the regression strategy also to be defined in this particular system. So for retesting, or even if there is a change in the requirement, so that change in the requirement, so while you are before implementing the change itself, like you will do a impact analysis, right? So based on the impact analysis, you will get to know what all the system items are getting impacted with this. So that particular system item related testing only we will do, that is called regression testing. So while we are defining system integration test strategy, we have to define regression test strategy also, because to run complete cycle of integration testing, so we need a lot of time, and we need a lot of efforts as well. So we need a lot of engineers or the resources, or these kind of all things. So that is the reason. So it is waste of time as well. Like if the particular item is not affected by the change, then there is no need to touch that particular thing. So that is the reason we have to come up with regression test strategy. So coming to the base practice 3, develop specification for system integration test. Develop this test specification for system integration test, including the test cases for each integration step of the system element according to the system integration test strategy. So we have a strategy defined how to test this particular system. So based on that, we have to define a test specification. The test specification shall be suitable to provide evidence for compliance of this integrated system elements with the system architecture design. See, here it comes, the system architecture design. So based on the test strategy, we have to define test specification. Okay, and there are 4 different elements, or 4 different subsections in this. So the interface descriptions between system elements are an input for the system integration test cases. So we have in architecture design, we have defined system elements, and we have defined interfaces. So that also we have to ensure that interfaces, system architecture design we have defined interfaces, right? So those interfaces also should get covered in this system integration test specification, or we have to ensure ensure it is covered or not. Okay, the second thing is compliance to the architecture design means that The specified integration tests are suitable to prove that the interfaces between the system items fulfill the specifications given in the architecture design. So we have to see like all the interface, entire architecture design is covered in the interface or not. So the next thing is the system integration test cases may focus on the correct signal flow between system items, the timelines and timing dependencies of signal flow between system items, the correct interpretation of the signals by all system items using an interface, the dynamic interaction between system items. So while we are defining a system architecture design, so we have come up with this dynamic behavior of the system, right? The same way, like while we are defining the test cases as well, we have to see the correct signal flow between the system, means like from one system to other system, how it is communicating, so how much time it is taking, or on time it is see if it is taking 1 millisecond, okay, and if it should ideally take 0.5 millisecond, then that's when like a 0.5 milliseconds delay is there, right? So we have to identify these all kind of things when we are defining a test case. The correct interpretation of the signals by all system items using an interface. The correct interpretation means like is the proper signal is going from one system item to another system item, we have to ensure. And the interfaces means like the interfaces, how it is communicating also you have to ensure on. The dynamic interaction between the system items, we have to the dynamic interaction between system items is also we have to ensure on. See, when it is dynamically one software unit, one software element is behaving in one way in while it is exposed to different dynamic environment. So one time it will be a sender, one time it will be a receiver, or one time it will be a parent, one time it will be a slave one time. So this is how it is, this is how the see when the system element is exposed to different environments, so one time every time the behavior of it will get changed. So the dynamic interaction between the system elements also we have to ensure the coverage of it. The system integration test may be supported, fourth one I'm reading. So the system integration test may be supported using simulation of the environment. So what the example, hardware in the loop or hill simulation or vehicle network simulation, digital mock-up, these all are the examples. So why we will use the simulation environment is, see, we will have a prototype at every, when you are working in a system, when you are working in a system environment, then you will have different samples or the different levels of level of samples you will get as a prototype. So which involves lot of cost. So when you develop a complete system with the hardware, mechanical and the software, everything, like we will have so many samples in between, or which doesn't have any use after that, which involves lot of costing. So our simulation will help us to replicate or to make a similar or the graphical representation of your system, so which we can test without harming the entire system. So with the simulation, so we can correct the design, we can get the design flaws as well, and even the behavior flaws as well, and even like the wear and tear of the system. So because it is a simulated environment, right, so the physical wear and tear will not be there, and it won't involve much cost when compared to, see, if you want to create a prototype every time, then it involves a lot of time as well, and even a lot of money it involves in. So that is why we have to get a simulated environment to test the system integration. So this is the fourth one it talks about. BP4 talks about integrate system elements. So integrate the system element is, according to the integration test strategy, we have to integrate the system elements. We spoke about while while we spoke about process outcomes. So we have a defined system integration strategy based on the system architecture design. So based on that strategy, we have to integrate the entire system. So what is the sequence of it? So here it is, one note is here. So the system integration can be performed stepwise, integrating system items. Example, the hardware elements are prototypes as prototype hardware, peripherals, sensors and actuators, mechanical integrated softwares, and to produce the system consistent with the system architecture. So I said, right, so while you're assembling a particular product, so if it is an automotive thing, so first of all, for the entire body of that, like you will have a contour weights, or you will have so what should we assemble first? Do we assemble engine first, or do we assemble wheels first, or do we require gearbox at the first item? Or this is how we have to think. All the hardware peripherals we have to think on, or which system. See, your entire car will have so many systems in place. So if your car or your automotive thing is a system of systems, I can say, like we will have a we will have ADAS in place, we will have infotainment, everything is a system there. So we will have a system of systems. So the integration of one system, so I'm talking about one system or the entire car, like what we will take as a first thing. So what is the sequence of integrating it? Sequence of integrating system items, this best practice talks about it. So we have to define the sequence of the integration items in the system integration strategy. Your BP5 talks about select test cases. So we have a system integration test specification in place with all the aspects of system architecture design covered, and we will have a system integration regression strategy as well. So while we are testing the system, then we have to pick or select, okay, a particular or applicable to the system integration. Select the test cases, and which will ensure the sufficient coverage according to the system integration test strategy and the release plan. BP6 talks about perform system integration test. So we have integrated system in place, we have defined the test cases in place. Then what is the next step? Is like we have to execute the defined test cases, right? So this talks about execution. BP6 talks about execution of or run the test cases defined. Okay, BP6 is like perform the system integration test according to using the selected test cases, record the integration test results and logs. So while you execute it, you will have a result as an outcome of it, right? When you are defining a test specification, you have a test case ID, test case description, what is the expected outcome of it, what is the behavior, what is the input criteria, what is the output criteria, and what is the outcome of it, and is it mapping with the expected outcome, is the actual outcome is mapping with the expected outcome. If it is not, we have to mention it as a failed test case. If it is yes, then we have to make it as pass. So if it is failed, what is the behavior expected? What is the behavior recorded? So you have to log a bug. Okay, you have to log a bug in your tool or your Excel sheet based on the behavior, actual behavior of the system. And you will have a supporting logs also when you are executing the test case. So you will observe a perfect or a behavior. Okay, that particular behavior you will get as an outcome as logs. So you will have a set of okay, you can understand logs, right? So what is the outcome? You have a multiple qualitative numbers, qualitative kind of thing, like you will get as a log. So those logs also you have to attach sometimes when you are logging the defect. BP7 talks about establishing bidirectional traceability. So this bidirectional traceability, as every time I say, like this bidirectional traceability we have to ensure in between system architecture design to system integration test specification, and from system integration test specification to system integration test results. So two traceabilities we have to ensure on. First thing is system architecture design to system integration test specification, and system integration test specification to system integration test results. Two traceabilities. And BP8 talks about ensure consistency. Consistency, every time I say, like we have to ensure on bidirectional traceability and the review aspect as well. So we are bidirectional. Once the bidirectional traceability is confirmed, then you will say like the entire aspects of the system is covered. Okay, when you have reviews in place, proper defined reviews in place, then you will know that the particular thing is reviewed perfectly. It is undergone multiple reviews through the peer review or the subject matter expert review or your engineering head review. These all reviews, levels of reviews. If the system is undergone, then it is said like it is it ensures the consistency of the entire system. Okay. And BP9 talks about communication. Communication will happen in terms of email, in terms of minutes of meeting if it is verbally discussed in meetings, or a configuration management tool generated automated email. So the output work products are system integrated test specification, system integration test plan, system level review records, or communication records, or your integrated system as an outcome as well, and the review records, traceability record, and even the system integration test report as an outcome. Yeah, thanks for your time. If you like this concept, subscribe to my channel for more concepts on automotive. Thank you.